The final part of this video, we're going to talk about temperature. Okay, so the temperature, the basic for measurement of temperature is based on the Zero's law of thermodynamics. So you need to find out what does it mean by Zero's law of thermodynamics if you have not learned so. But we're going to encounter this particular subject in the future. And we are actually, when we talk about the Zero's law of thermodynamics, we talk about the thermal equilibrium, which is independent of the nature of the system. So when actually the temperature raised to a certain equilibrium, and then it will give you certain numbers, okay, certain values. That is the temperature at that particular time. Okay, it tells us if two systems are in thermal equilibrium or not. Because if let's say you are taking a thermometer, if let's say it doesn't arrive into any equilibrium, then basically you can see then there is a fluctuation of the thermometer itself. But if let's say once it reaches a thermal equilibrium, then it will give exactly. If let's say you put a thermometer, right, in a boiling water, then you'll be able to tell in a cool water, for example, and then suddenly you can see there is a drop of the mercury inside the thermometer, and it will achieve the equilibrium at that particular time, and that is the temperature that will give some numbers. Okay, so measuring device are systems that can be brought to thermal equilibrium with the system of interest. For example, here we can use thermometers, we can use thermocouples, resistant thermometers, bimetallic thermometers, radiation pyrometers, and so on. These are the equipment or the units that can use to measure the temperature. The unit of temperature is given in terms of the degree Celsius, Fahrenheit, degree R or Kelvin, and related to each other using the following equations. So there are several equations, several conversion that you can use, which is, for example, you want to convert the Kelvin, the temperature in degree Celsius into Kelvin, then you just need to add on 273.15, then you'll be able to get Kelvin. Okay, and if let's say you want to calculate the Fahrenheit to Rankine, then you'll be able to get, just to add on 459.67, then you get temperature, the new temperature in different unit. Similarly, if let's say you are converting from Kelvin to Rankine, or you are converting the degree Celsius to Fahrenheit. Okay, so these are the formula that you can use that can help you in order for you to calculate or determine the process, the temperature in when you are actually encountering the problem with respect to mass and energy balance. There are some activities that I would like you to have a look that you can do on your own first. For example, here, one problem is that the specific gravity of a gasoline is approximately 0.7. So please determine the mass of 50 liters of gasoline. That is the first task. And you're given that the mass flow rate exiting a refinery tank is 1150 kilogram per minute, consists of a mixture of gasoline and kerosene. So the kerosene is given as Sg equals to 0.778, and estimate the volumetric flow rate in liters. So you need to determine what is the volumetric flow rate of these particular mixtures in liters. Okay, so that is the first task that you may want to do. The second one is, assuming the price of gasoline in France is approximately 5 francs per liter, and the exchange rate is 5.22 francs per US dollar, how much would you pay in dollars for 50 kilogram of gasoline in France, assuming gasoline has a specific gravity of 0.7? What would be the same quantity of gasoline cost in the United States at a rate of $1.2 per gallon? So you may want to use the calculation, the unit and dimension that you have learned before, and then you may want to try to solve this particular question. Okay, so here I can say that throughout these lectures you have learned to understand different type of process variables where we have come across in terms of molecular weight, mole fraction, mass fraction, flow rates. We also have learned about concentration. There are different type of expressing the concentration, such as molality, okay, molar concentration, and then mass concentration, okay, and then molarity and molality. So you need to differentiate between those two both. And then you have learned about pressure. So there are many type of pressure, which is gauge pressure, absolute pressure, atmospheric pressure, So you need to actually differentiate what are the difference between this type of pressures. And you also learn about temperature. So there are different units that you can use to measure the temperature, and there are different units of temperature that you also need to understand and how to convert from one to another. Okay, so here these are all process variables. If you try to understand this, it will make your life simplified when you are actually doing mass and energy balance calculation later. Thank you very much. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh, and have a good day.